Okay, this is Redox video number 3. We're going to talk about how to write half reactions. So just like we did in the last video, first thing you have to do before we could figure out anything is we want to identify what species is oxidized and which one is reduced. So first step would be to assign oxidation numbers. So here, iron is a free element all by itself, so it's going to be 0. This one's nice and easy. Zinc gives you the charge is +2. Over here, iron gives you the charge is +2, and zinc is 0. So the next step is identifying what's oxidized and what's reduced. So we see that iron goes from 0 to +2, and zinc goes from +2 to 0. Remember, when you're oxidized, oxidation is loss of electrons, so you become more positive. And iron is the one that's becoming more positive. You think about a number line. It's going from 0 to +2. So when you want to write a half reaction, we'll start with the half oxidation reaction. You write what does it start as on the reactant side and what it goes to on the product side. So iron starts as 0 and it goes to iron +2. That's the first step. The second step is to make sure that it's balanced in terms of mass. So I have 1 Fe here, it's fine, and I have 1 Fe here. So we balance in terms of mass. The next step is to balance the charge. So on the left side of my arrow, my charge is 0. On the right side of the arrow, your charge is whatever your superscript is here, +2 times your coefficient. I'm right now at +2. I need to make sure that my charges are balanced. So if it's 0 on this side, I'm going to make sure that it's 0 on the product side. So what I'm going to do is add in 2 electrons to balance this out. So 2 times -1, the charge of an electron, gives me -2. And this was +2, so over here my right-hand side is 0. I'm going to rewrite this to make it a little neater. Okay, so we balanced in terms of mass and we balanced in terms of charge. Now here's a trick that will help you. For oxidation, when I write Leo, I write an arrow like this. Loss of electrons is oxidation. I write my arrow like this to remind me that my electrons have to go on the right of the arrow. So if here's my arrow, the electrons are going to be on the right side, or the product side. So it's a way to help me remember, put your electrons on the right when it's an oxidation half reaction. Now let's look at the reduction half reaction, because you can't have oxidation without simultaneously reduction at the same time. So in this reaction, the one that's reduced is zinc. So the half reduction reaction would be zinc starts out as +2. What is it on the left and what does it go to on the right? And it goes to zinc 0. Okay, we need to balance our mass and balance our charge. I have 1 zinc and 1 zinc. My mass is balanced fine. My charge on the left right now is +2 on the reactant side, and on the product side it's 0. That's not okay because the charge has to be balanced. So I'm going to add in 2 electrons, because that's going to give me a -2 charge to balance out the +2 charge to make this equal to 0, and the right-hand side is 0 already. Just like we had with Leo, with gain electrons, I make my arrow like this to help me remember that my electrons for reduction have to be on the left side of the arrow. So if here's my arrow, I have to put in my electrons on the left of the arrow. Okay, here's another example I want you to write down. First step, assign oxidation numbers across the top. Al is 0, Fe is +2, Al is +3, Fe is 0. Next step, identify what's oxidized and what's reduced. So here, what's oxidized is going to be aluminum. It's going from 0 to +3. And what's reduced is going to be iron, because it goes from +2 to 0. It's gaining electrons, are becoming more negative, or the oxidation number is decreasing. So we identify what's oxidized and reduced. Now we could write our half oxidation and half reduction reactions. So let's write our half oxidation reaction. We're going to start by looking at what's oxidized, what is it on the left, and what is it on the right. It's the first step. Next, we're going to add in our electrons. So it's already balanced. We have 1 aluminum, 1 aluminum. So let's add in our electrons. We have a charge of 0 on the left and a charge of +3 on the right. So I'm going to add 3 electrons because +3 minus 3 adds up to 0. So now I'm balanced in terms of mass and charge. You could also add the coefficients in as they appear in the equation. So I would take this answer, that's the easier way I think, and absolutely correct. We'll also take it as it appears in the equation. So 2Al0 goes to 2Al plus 3. Are we balanced in terms of mass? 2 aluminum, 2 aluminum. Yes, we are. What about charge? I have 2 times 3 is plus 6. So how many electrons do I need? 6. Because positive 6 minus 6 equals 0. If my charge on the right is 0 or the product side is 0, the charge on the reactant side has to be 0 as well. So we're good. Okay, so let's look at the reduction half reaction now. We see that iron was reduced. So iron starts out as plus 2. You know, for now we'll leave off the coefficient. And it goes to iron 0. For reduction, I want to write my electrons to the left of the arrow. So I have to add in 2 electrons here to balance out the positive 2 charge of the iron. So we have plus 2e minus. You could have also done it with the coefficient. So if I have 3Fe plus 2, and on the product side I have 3Fe0, I'm balanced in terms of mass, 3 and 3. My charge over here is 3 times 2 is 6. So I'm going to put in 6 electrons because that's a negative 6 charge. To balance out the plus 6, I'm 0 on the reactant side and 0 on the product side, so we're good. Okay, one more. The diatomics are a little bit more complicated. So I'm going to put my oxidation states in. First step. Second step, identify what's oxidized and reduced. What's oxidized is becoming more positive. So hydrogen is becoming more positive. What's becoming more negative? Oxygen. So to write my half oxidation reaction, what we're going to do is start out, what is it on the left, and what is it on the right? Hydrogen goes from 0 to plus 1, I'm sorry. There are 2 hydrogens. You cannot leave off that little diatomic 2 part. So I have to balance out my hydrogens and put a 2 over here. If I put a 2 there, I have to add 2 electrons here because 2 times plus 1 is plus 2, so I need 2 electrons. For half reduction reaction, what's happening is oxygen, got to keep the 2 because it's a diatomic, is going from 0 to negative 2. I have 2 here, so to balance out the oxygens, I need 2. You first have to balance in terms of mass. 2 times negative 2 is negative 4, which means that I need a negative 4 charge on my reactant side, so I have to add in 4 electrons. So in general, first balance the mass. Make sure I have the same amount on each side. 2 and 2. Then balance the charge. To figure out the charge, you multiply the coefficient 2 times the superscript negative 2, which gives you negative 4. So on the reactant side, I need a negative 4 electrons.